the boundary conditions, the constraints, and the loads. Now, because we don't have load and constraint sets created, it's actually easier to use the toolbar because it'll prompt you for a load or constraint set. Or alternatively, you can always pre-create and have a template and have that automatically loaded when you start FEMAP that has a load and constraint set predefined in your new models. So if you go to your constraint toolbar, you'll go in and create a constraint on a surface. Just give the constraint set a name. Now when I select surfaces, I generally like to set my pick mode to pick front. Makes it easier to select, especially when you're selecting cylindrical or flat surfaces. I also recommend you use the preview selected button to show that you've selected the right surfaces. Click OK. And we could just call this the fixed pin or fixed key base. You don't really need to name it. However, I like to give them logical names. Pick that flat surface at the base of the key for a second constraint. And set your surface constraint to sliding along surface or asymmetry. So sliding. Done creating constraints, now it's time to create the load. So under load toolbar, you want to say create load on surface. Give it a load set, and I usually call this load set the arm slot loading. I'm going to rotate my view around. And I like to use the view toolbar and zoom into that area. I'm going to select that surface at the end of the slot. I'm going to make this 100, call this load 100 Newton slot load. And for direction, I'm going to use a vector. I'm going to use specify. And in this case, I'm going to set my method to tangent. I'm going to pick this curve here, pick the end of the curve, preview it so you can see that direction, hit OK, and we want this value to be 100. If they cannot see if you want to turn or better display the load, just toggle off the elements. I'm going to go back to my previous zoom, turn my mesh back on, and we're going to do one more load on surface. We want to preload the cap nut. So I want to pick that flat surface at the base of the hex on the cap nut. Select that. Let's do a normal to surface load. I'm going to make it minus 25 newtons. And we're going to call this the nut preload. Hit escape to get out of that. And now you're ready to analyze the part. So create an analysis set. You can collapse your model tree and your geometry tree. Right click on Analyses, say Manage. Create a new analysis set. We'll call this Assembly Contact. Hit OK. And I like to expand the master requests and boundary conditions trees so that you can see that the active constraint and load set were automatically assigned to this analysis set. Hit the Analyze button, and this will bring up the analysis set monitor. And in this, you can point out that you have different options. You can expand this window and talk about how you can just display the simple log file, or you can look at more detail, the F04 file or the F06 file. I'm going to pause this recording because this takes a little over a minute, and we'll come back when the results are loaded. Okay, my analysis is complete, and you can confirm that by the lack of any error messages. And in your messages window, you'll see that you're going to get the creating, cleanup, and cleanup of output set 1 is complete message. You can close out the analysis monitor, and you right click in your graphics window and bring up the post menu or post data menu. And you can see that it's automatically set to total translation and solid von Mises stress. Click OK. And on your post toolbar, just simply select contour view, display the stress contours. You see you got 17 megapascals as the maximum stress. You want to set a deform view. Now on this toolbar, or on the post toolbar, in this case I've got it set to actual deformation. You may want to set it to scale deformation. I personally prefer actual, and I'll change the scale to 500 to 1. Because we have a maximum deformation of about 0.12 or 0.01 millimeters. So we've got a very small deformation. At this point, I'd also want to look at the individual parts. So there's a couple ways we could do that. Now, either you could go to the group operations, generate solids, or on this toolbar, on the group toolbar I've provided, there's a group generate solids icon. Select all your solids, create multiple groups. OK. Expand your groups. And if you look at group 3, which is your pin, or group 1, which is your arm, you can activate it and view active. And the other thing I like to do now is, since everybody's seen the mesh, you could just go into your toolbar, and under view style you could basically go turn off the filled edges. So rotate the view around. You can see the maximum stress is occurring on the control arm, is occurring at the bottom of the arm. If you activate group 3, you can see it's at the base of the pin. And that's where the highest stresses are, which you'd pretty much expect because you're using glued contact and you're actually locking the parts together, or a quasi-rigid connection. I'm going to turn off the view active there. And now at this point, what I'd like to do is turn off the deform shape. And on the post toolbar I gave you, you have the dynamic cutting plane and the isosurface. You could see either one or both, but these are both useful for showing where the different stress levels are in this model. And I also like to set a specific level and set a specific delta. So you can just click through it, see where the stresses are the highest or the lowest. Of course, you could also use your dynamic cutting plane and walk through the model. Okay, we want to do one more analysis. What we want to do is we're going to change our contact from the glued contact, which is what we set up when we set up our connections. So I'm just going to expand the connections tree and the properties subtree. I'm going to say edit that property. I'm going to change the contact type or connect type from glued to contact. I'm going to call this linear contact. And remember that when you change the contact, you should always set the defaults button. I'm going to add friction about 0.7. It's just a linear friction coefficient. And I'm going to set a maximum surface distance to about 10. And I can rerun the analysis. So we'll do that in the next step.